All right, let's take a look here. So today we're going to talk about linear inequalities. We're going to solve some linear inequalities here. So let's take a look. First of all, what are some inequalities? Inequalities. What's an inequality? Do you guys know? You guys know what's an inequality? All right. What kind of symbols represent inequalities? You have things like, yeah. What's that symbol? What does that mean? Greater than. What else? Less than. Greater than or equal. Less than or equal. Okay, so we have these symbols. These symbols are used, we use to compare. Numbers. Okay, so let's go back and think about this comparison. Some of you guys, this is still kind of review, this idea here. And here's a real number line. Okay, you have 0 in the middle. And of course, what do you guys have on the right? Positive numbers live to the right of 0. Negative numbers live to the left of 0. And here's an important fact that you guys always want to remember. Here's a fact. That larger numbers live where? To the right. Good. Larger numbers live to the right. What that means, the further you go to the right in the real number line, the bigger the number. Okay? So the further to the right on the real number line a number lives, the larger the number. This also implies that what? Smaller numbers live where? Larger numbers live to the right, and we'll say smaller numbers live. Where do smaller numbers live then, if that's the case? To the left, good. Okay, so we're going to use this idea, for example, when we compare numbers, if you guys remember, 2 versus 11. We're going to use one of these symbols here. In the beginning here, we're going to use mainly these two. So, 2 versus 11, which number is larger, 2 or 11? Why is 11 larger? Right. Anybody know why is this number 11 larger? In other words, you see this inequality? We're going to have this inequality, if you want to think of it, this some people describe as a mouth. Is that right? So back in the day, we used to call that Pac-Man. Okay, Pac-Man people. Anybody here know about Pac-Man? Okay. Or not, if you don't like Pac-Man, what do you like instead? Jaws, maybe? Okay. So if you don't like Pac-Man, maybe you like Jaws instead. Here's Jaws. In other words, Jaws always opens to the what? Larger number. Or Pac-Man. Larger number. So 11 is bigger. Now, you can verify that on the real number line because you can say, okay, wouldn't 2 be maybe over here? Right, you go 1, 2, and then maybe 11 is over here. What number's to the right? 11. So 11 is bigger. Okay, so Jaws is going to open to the 11. So you guys already know this. This is pretty simple, I guess. Right, what about this example? What if you had negative 3 versus negative 7? Could you guys now tell me which number is larger? Negative 3? How do we know? Okay, well, let's see. What would negative 3 be? Here's negative 1, negative 2. This will be negative 3. And then ultimately you get up to what? Negative 7. That's true. Negative 7, negative 3. Which one's on the right? Is that negative 3? So which sign am I going to use? Or how is Jaws going to open? It opens to the what? Good. Opens to negative 3. Okay. What I like to do is I like to talk about money. I like to tell people, okay, if this were money, which is like having more money? In this case here, now I'll erase the jaws since you guys get the point, right? In this case over here, you may say $11 is better than what? $2. It's more money, so jaws opens to the bigger money. What about this scenario here? What does that -3 mean again? It means you owe 3, and it means you what over here? Owe 7. Is that true? So owing is not really having money, but in a sense, what situation is better? Is it better to owe $3 or to owe 7? Why is it better to owe 3? It's like having what? More money, even though it's owing. Okay, so if you don't want to go with that kind of analogy, that's fine. Just do what? Plot your numbers on the real number line. Larger numbers are where? To the right, smaller or to the left. Okay, you guys okay with that? Is that easy? All right, let's go with a couple more examples here as a review. How about 13.8 versus maybe, I don't know, -6.5? Okay? Which is like having more money? Or which number is larger? Which is smaller? How is JAWS going to open? JAWS opens at 13.8. Why? Well, isn't 13.8 a positive number? So 13.8 may be where? Something over here. Here's where 13.8 might be. What about the -6.5? Where's that going to be? Maybe to the left over here, 6.5. Which number is on the right? 13.8. So JAWS opens at 13.8. What if you thought of money? Would you rather have $13.8 or would you rather owe $6.5? Anybody know? What would you rather have? 13.8. Is that true? Okay, because having money is better than what? Owing. Let's look at the last example. Okay, how about -5 versus 0? What do you guys think? Which is a better situation? Would you rather owe $5 or would you rather be broke? Right? What does being broke mean? Broke means you have no money. So which situation is better? Owing $5 or being broke? What do you think? You rather be broke? Okay, so how's JAWS going to open? To the 0. Good. Okay, double check here. Isn't 0 to the right of a -5? Where would -5 be? If this is -6.5, let's say -5 is over here. -5, a number over here versus 0, which number is on the right? 0. Okay, so we have the correct inequalities here if you guys look at it that way. Okay, so wouldn't you guys say that this fact is a pretty useful fact? Okay, so we can use the real number line as a fact. We can also deduce what's larger as a fact just by thinking about having money, owing money. Okay, you guys okay with that? All right, let me ask you a question then, because what we're going to have to start working on today, first of all, is a concept called notation, associated with our solving, what do we call linear inequalities. So I want to focus on those kind of aspects of this, but before I do that, let me ask you some questions. Here's a big question, okay? What if I asked you to describe to me what numbers are, let's say, greater than, numbers that are greater than, can you describe numbers? Then let's say 5. Let's put it over here. So what numbers are greater than 5? So what do you guys think? What does greater than actually mean anyway? What does greater than mean? Has to be larger than. Is that right? Or more than? Okay, so greater than, more than, larger than. Could you guys tell me what numbers are larger than or greater than 5? Okay. You're going to tell me 6. Isn't 6 larger? That's true. What else? 5.1. Good. What else? How about 5.23? Okay. How about 5 and 3/11? Okay. How about 18? How about 1,000? How about 1,000.6? In other words, ladies and gentlemen, are all of these numbers more than or greater than 5? How many numbers do you think are more than 5? Well, if we start including the whole numbers and the decimals, what do you guys think? That list goes on what? Forever. So you see these 3 dots that I put here? That implies that this list kind of continues on forever. If you can see a pattern, the pattern really is just numbers. I'll tell you what it is, numbers greater than 5. That list keeps going forever. And the problem is, if you had to list these answers or the numbers that are greater than 5, you would die before you ever what? Finish that list. Because that means that goes on forever. But mathematicians have come up with a way to describe to people numbers that are greater than 5. Okay, so that you don't have to die to actually list it all. Do you guys appreciate what I'm talking about? If you had to keep giving me numbers on that list, you would die before you finish the list. And if your children picked up the problem where you left off, they would die too. Okay, because that list goes on what? Forever. It never ends. So what we do in mathematics is we describe this list with a picture. Okay, and that picture is called a graph. So sometimes they'll say to you, let's graph numbers that are greater than what? 5. Okay, now here's what I want to say. We're going to let x be an arbitrary number. So here's what the basis is. If x is an arbitrary number, how am I going to describe numbers that are greater than 5? Well, let's write it that way. X, arbitrary number. Greater than, well, what symbol is the greater than symbol? Isn't that the symbol? So we're going to put numbers greater than what? 5. So I'm describing here, this isn't the picture yet. This is the phrase, numbers, we don't know what they are, but we know that they are what? Greater than 5. So, they're going to say to you now, to graph, ladies and gentlemen, graph, if you will, numbers that are what? Greater than 5. Okay? And so how do we graph numbers greater than 5? Let me show you how we do this. Okay? Draw your real number line. This is what I do. Here's a real number line. And where is 0 on this real number line? It's in the middle. Okay. So put 0 in the middle here. And then now, let's locate this reference point. What's the reference point? 5. So if I want to describe numbers that are greater than 5, I have to find the number 5. Where would 5 be on the real number line? To the right or to the left? Good. It's to the right. Here's where 5 might be, right? Now I'm going to say to you guys, for the moment, put a circle around the location where 5 might be. Just for the moment. We're going to use some high school notation and transition to college notation. Some of you guys might remember this. Some of you guys might actually know the college notation. But these are numbers. This is where your reference is. We have to describe numbers that are greater than this reference number 5. Now, let's use the fact. Larger numbers live where? To the right or to the left? Live to the right. So here's 5. Numbers larger than 5 or greater than 5 live where? To the right. So what you're going to do now is shade the portion of the real number line that is now to the what? To the right, and put your arrow.